Hi guys, it's Miss Young. I hope you guys are all staying safe and healthy out there. Here's a quick video, or maybe not that quick, but here's a video recapping all of Unit 6 to help you review for that quiz in Canvas. So, in order for us to be prepared for that quiz in Canvas, what we're going to talk about is rational and irrational numbers. We're going to talk about exponents and radicals. We're going to talk about the Pythagorean theorem. Talking about sine, cosine, and tangent. And lastly, the complementary angles of sine and cosine. All right, so breaking it down, those first two pieces, we've learned them before we closed school. So those two pieces, any standards that fall under those two pieces are irrational and rational numbers, are exponents and radicals. Those are standards that you can use to bring up your grade, and that's going to be on your quiz 3 for unit 6. These last three concepts, these are things that are in your Canvas calendar, so you can always go back and review them before this quiz, or you can just use this video as a really quick review on all of those things. The quiz will help give you feedback on how you're doing on those three standards as well. That way you know what you need to work on and be ready for Algebra 2. So starting with our rational numbers. Remember, those are fractions. Any number that can be represented as a fraction, meaning we've got fractions, whole numbers, we've got negative numbers, we've got repeating decimals, we've got ending decimals, and we've got perfect squares. Okay. To remember perfect squares, something like square root of 4, I know that's 2, perfect square, because there's nothing left over inside of my square root, and if you plug that into a calculator, you're gonna get just a whole number left over. Ending decimals, I'm talking about, like, for example, 0.5, because I know that's 1/2, and that's a fraction, and that's rational. Repeating decimals, like 0.3 repeating, that's actually 1/3. Fraction, rational. Perfect. Okay. Pause if you need this definition. I'm wiping it now. Irrationals. Basically everything that's opposite of your rational. So it cannot be a fraction. That means we've got never ending and, because it has to be both of these things, never ending and never repeating decimals. Okay. And you've also got your non-perfect squares. So never ending, never repeating, such as pi. Non-perfect squares, like square root of 2, or maybe square root of 3, right? You know that there's no two numbers or no numbers that when you multiply by yourself, you're going to get 2 or 3. That's what a non-perfect square is. Also, if you plug it into a calculator, you're going to get some super long decimal that doesn't repeat and never ends technically. Okay. When we talked about rational and irrational numbers, remember we made that Venn diagram, something like this. So in here, I've got rational answers. And on this side, I've got irrational answers. Okay. Remember, I'm going to denote rational being R, irrational is I. So, surefire way to always get a rational answer. Just make sure both of your things that you're adding, subtracting, multiplying, or dividing are rational. Okay? Partially true for irrational answers. If I'm adding two irrationals or subtracting two irrationals, I will get an irrational answer. Okay? Special case is this. If I multiply two irrationals or divide two irrationals, I could get either type of answer. Okay? We'll give some examples at the end. But remembering that also if I mix in a rational plus an irrational, or subtracting an irrational, multiplying an irrational, or dividing an irrational, I will get irrational answers. Okay? My special case here was, remember, if I took the square root of 5, which is irrational, and multiply it by the square root of 2, which is also irrational, I get square root of 10, which is still an irrational answer. So it falls under irrational. However, there is an example where we would fall under a rational answer, and that could be something like square root of 2 times the square root of 8, giving me the square root of 16, which is 4. Whole number, it's rational. Perfect square, it's rational. However, these two things were not rational. They were both irrational. Okay. Moving on to my exponents and radicals. Okay. I'm going to say x to the a power. Remember, this is your exponent. And this is your base. An exponent tells you how many times to multiply the base by itself. Meaning, for example, if I had 5 to the third power, that's telling me I need to take my base of 5 and multiply it by itself 2, 3 times. And that's what exponents do. Okay. We got into radicals as well before we left school. We've got, let's say, a x to the b power. Remember that everything inside underneath my radical symbol is your radicand. And the number that lives right out here outside of your radical symbol, small superscript right there, this is your index. Okay? If there's no number, then it's actually a 2. Remember that we could rewrite this as an exponent. Being x to the b over a. Okay. Notice how here's my radicand, x to the b. Okay. And this denominator of my exponent came from my index here. Pretty cool, right? So let's see a quick example, because that was one of the last things that we left on. So if I had square root of 5 to the second power, that's the same thing as saying 5, 2, okay, radicand over 2. Remember, nothing means it's a 2. Maybe 2 and 2 was not the greatest example. Let's look at 3. So that's a cubed root of 7 to the 4th, right? Radicand, 7 to the 4th. And then we do your fraction symbol on your exponent, and 3. That was your index. Okay, easy peasy stuff. Remember also we talked about solving with exponents and radicals. So if I had x squared was 81, the way I would solve this is, since a power here, the opposite is a square root. So I'm going to square root both sides of my equation. Just like how you solve for any x equation, you're going to do the same thing on both sides. Square root it because my power and my radical would cancel. And x is the square root of 81. You can plug that into a calculator and get 9. Okay. If it were a different power, for example, x to the third, I need to take the third root of that. Okay. And if we went backwards, let's say the square root of x is equal to, let's say, 5. Okay. Since as we saw in the previous example, we saw that the exponent will cancel with a radical. Same thing here. Since I have a radical, I need an exponent. I'm going to now raise everything to the power of 2. So that's going to cancel out that radical. I get x is 5 to the power of 2, which is really x equals 25. All right, moving on to our Pythagorean theorem. That's your a squared plus b squared equals c squared. Remember that this only works for right triangles. Okay, so if I were to give you a right triangle and I told you that I had different lengths for those sides, remember that your A and B are always legs. Okay, C is always your hypotenuse. always. Okay. So example for you then is if I had a right triangle, I've got 3, I've got 4, I have no idea what my hypotenuse is, plug it into my Pythagorean theorem. Since I've got 2 legs here and no hypotenuse, that's the way I'm going to follow. So I've got 3 squared plus 4 squared, because those are my legs, equals, we'll say, x squared, because that's something I want to find. I know that 3 squared is 9, 4 squared is 16, and still unsure about this x squared. We can't do anything with it, okay? Add those together, combining like terms, I've got 25 is x squared. Now we've got this equation that we've just been talking about, how I need to get x by itself. I know that a exponent can be canceled with a square root. So my next step is to square root my entire equation. And the square root of 25, I get x equals 5. Okay, this works if you have any 2 sides, even if you had the hypotenuse. So for example, let's say I had a squared plus b squared equals c squared, and I had a triangle that said 2 and 7. That's a 7. Okay. I have my hypotenuse, but I don't have all my legs. Okay. So what you're going to do is take your 2 squared plus x squared that you don't know equals 7 squared. 2 squared is 4 plus x squared equals 49, because that's 7 squared. And I have to solve it like any other equation. Subtract my 4. X squared is 45. Now I need to square root. Okay. X equals the square root of 45. Now, it's okay to be done right here. However, if I asked you to put into like round to the nearest tenth or something, that's where you would need to go and look for a calculator. Now, if you don't have a scientific calculator at home, what you can do is use Desmos here. So Desmos has a scientific calculator. You would click that. And I want to know the square root of 45. And there you go, 6.7. Perfect. Okay, moving on to our sine, cosine, oops, and tangent. Super easy way to remember these terms is your SOHCAHTOA. Okay. The SOH part refers to sine being opposite over hypotenuse. My CAH, ka, refers to cosine being adjacent over hypotenuse, and TOA, TOA, referring to tangent being adjacent or opposite over adjacent. And what I mean by this is in my right triangle, and only for right triangles, okay, you're going to have something that's indicated as a reference angle. my opposite is always going to be across from my reference angle. Your adjacent always touches your reference angle, and hypotenuse is always your longest side and the side that is opposite of your right angle. Okay, this works even if I drew the same triangle, but let's say my reference angle is here now. Now it has to change where my opposite has to be here because that's where it's opposite of my reference angle. Adjacent needs to be touching my reference angle, and hypotenuse is still there across from my right angle. Okay, so when we're trying to solve for sine, cosine, or tangent, I'm going to erase parts of these. Okay, the equation goes as following. Sine of theta, theta being a unknown degree measure, is your opposite over hypotenuse. Cosine of theta is your adjacent over hypotenuse. And lastly, your tangent is opposite over hypotenuse. Oh, not hypotenuse, sorry. Opposite over adjacent. Right? Okay. So if I gave you this equation, sorry, not equation, triangle, right angle there, and I said this was my reference angle of theta, and I knew 3, 4, and 5. To solve for sine, I know opposite over hypotenuse. Let's color these. Opposite. Oops, okay. Opposite in my yellow is here. And adjacent is here. And let's use pink. Hypotenuse is there. Okay. So all I need to do is follow my colors. Opposite over hypotenuse is 3/5. Adjacent over hypotenuse is 4/5. And opposite over adjacent is 3/4. Very cool, right? Okay. Not always will we be asking for just these ratios, these fraction answers. Sometimes I'm going to ask you to solve for theta itself, solve for the angle measure. So let's take a look at that. Since I know that sine theta is going to be 3/5, and I want to solve for theta, what you're going to do in your calculator, you would take the inverse. So it would look like sine inverse of all of these things. That would cancel out the regular sign and leave theta equals sine inverse of 3/5. So if we wanted to go and take a look at Desmos calculator, we should be able to find that there. So all I did was click to this function right here. I need sine inverse of 3/5. And then I want my answer right here. Right? 36.869. Continuing on, if I ask you to round to the nearest tenth, we've got 36.9 degrees. So back here, theta is 36.9 degrees. So that Desmos calculator, or if you have your own scientific calculator, is going to be your best friend for trigonometry. Okay. Last thing on my list was that we're going to talk about complementary angles of sine and cosine. Remember that complementary meant you need to add to 90 degrees, right? So if I had two angles, calling them alpha and beta, they have to equal 90 degrees. And the rule follows the fact that sine of alpha can equal cosine of beta as long as this is true. So for example, if I had sine of 30 degrees, that's going to equal cosine of 60 degrees, right? Because 30 plus 60 equals 90. In your homework from April 1st, if you are following along in the calendar, you saw a little more difficult problems. Let me find one really quick. So for example, I'm going to use sine of theta was equal to cosine 3 thetas plus 20. Okay. All this means is that I need theta plus 3 theta plus 20, and it's coming from here and here, equals 90. Okay. Combine my like terms, I've got 4 thetas plus 20 equals 90. Running out of space. Squeezing it here, hopefully. If I subtract 20 from 90, I've got 4 theta equals 70. And then you just divide by your 4. Theta equals 2, rounding to your nearest tenth even, 17.5 degrees. Okay, and that's how you do complementary angles of sine and cosine. I really hope this helps, and if you have any other questions, just go back and rewatch this video or look at the lessons in the Canvas calendar or email me. I am totally available. You have 1 week to do this quiz. It's going to close on the 28th, like at, oh no, I think I gave you until the 30th actually. It's going to close 11:59 p.m. on the 30th. If you have any questions, email me. Hopefully you know my email, right? ALYOUNG@fwps.org. Good luck, guys, and let me know if you have any questions.